my name's Joe. I'm currently doing my master in theology at the University of Vienna in Austria. As you can imagine, theology has a lot to do with the ancient world. And in addition, I did my bachelor's degree I did a second bachelor's actually in religion and classical studies from the City University of New York. This is such an outstanding book. It's called A Very Short History of Life on Earth, 4.6 billion years and 12 pithy chapters. They are very pithy, and it's an excellent read. And so how I want to do this is I'd love to kind of have us read selections together. Hopefully you guys will do the reading, and then we'll kind of like discuss it. And then I've taken some notes that this book actually ends essentially at pre-civilization. This is more of a history of evolution, which we're not going to obviously do the whole book at all. But yeah, and then have some stuff kind of human history, kind of some core concepts. You want to read that aloud, Roger?
Yes. Once upon a time, a giant star was dying. It had been burning for millions of years. Now the fusion furnace at its core held no more fuel to burn. Had no more fuel to burn. The star created the energy it needed to shine by fusing hydrogen atoms to make helium. The energy produced by the fusion did more than make the star shine. It was vital to counteract the inward pull of the star's own gravity. When the supply of available hydrogen began to run low, the star began to fuse helium into atoms of heavier elements such as carbon and oxygen. By then, though, the star was running out of things to burn. The day came when the fuel ran out completely. Gravity won the battle, the star imploded. After the millions of years of burning, the collapse took a split second. It prompted a rebound so explosive that it lit up the universe, a supernova. Any light that might have been existed in the star's own planetary system would have been obliterated. But in the cataclysm of its death were born the seeds of something new, even heavier chemical elements forged in the final moments of the star's life. Silicon, nickel, sulfur, and iron were spread far and wide by the explosion. Millions of years later, the gravitational shockwave of the supernova explosion passed through a cloud of gas, dust, and ice. The stretch and squeeze of the gravitational wave made the cloud fall in on itself. As it contracted, it started to rotate. The pull of gravity squeezed the gas of the cloud's center so much that atoms began to fuse together. Hydrogen atoms were pressed together, forming helium, creating light and heat. The circle of stellar life was a complete. From the death of an ancient star emerged another, fresh and new, our sun.
Very nice. Beautiful. Thank you so much. So, any kind of reactions to this description of the formation essentially of the galaxy? Have you? Because the thing is, I hadn't read this again. I mean, this is one of those things that you learn about in like high school science, but I actually I don't know. I read this again. I don't know exactly, couple of like about a week ago maybe, and I'm like, man, that really is amazing to think that like the stars all form originally with hydrogen, which is obviously has a single proton, and then literally through the combustion of hydrogen coming together, then we get helium. Okay, two protons, and then that's how and then that happens sequentially, kind of not exponentially in speed, but exponentially in terms of the number of protons that we get together, and this is how all the elements form. And the other thing that I didn't even know until I read this again recently was it's first in the final moments of a star's life that these heavier metals are formed, and then from the gravitational shockwave of the supernova's explosion at the center of the galaxy, now we've got a black hole here, and there's this supernova that pushes forward all of the material that the star is made of, or has combusted, essentially burned together, pushes it outward out of the center of the galaxy, and then that comes together in clouds of gas, dust, and eventually that pulls together, and that's how planets are formed, and that's we have these, metallic cores. I'm like, so amazing. I don't know if you have any thoughts, Roger.
I don't know that I have any thoughts beyond wondering why our sun was the second, or maybe the third or fourth. Why wasn't our sun the first?
You're saying at the center of the galaxy? So I'm not an astrophysicist, but my understanding is that you essentially have the Big Bang, which is something like 13. I hear different numbers. I've heard as much as like 20 billion before. I don't know what the latest estimates are, but that occurs essentially at what is today the center of the universe in a non-geographic sense. But it's the center of the universe in the fact that all things continue to move away from this point, because this is essentially the point at which the singularity occurred. All space, time, matter, energy was all together in this single point, mathematically incredibly small, expands outward from the single point, and we have the universe. I don't know exactly why there's already a sun, in the sense that there's already a star, but you have these massive mega stars. I don't know exactly what they're called, that are radiating out from the singularity, and then there's also just this cloud of material around them, but a lot of them are burning. And these mega stars, like there's a supernova, or there's an enormous black hole at the center of the galaxy that we're in, the Milky Way galaxy, and it was a star that is unimaginably large to us, that it just described its collapsing. And I don't know if there were already other stars that were already kind of orbiting it when it was a star before it became a black hole, or if kind of at the moment of it becoming a black hole, parts of the remaining hydrogen, for example, got pushed away and formed their own stars. But there's millions of stars at least in the Milky Way galaxy as well. So it's that all of these stars in the Milky Way galaxy, of which our sun is just one, are circling around a giant black hole, which is the result of like this unbelievably enormous star that went out X number of billion years ago, something like 5 billion years ago, I believe. So that's my understanding of how, again, that is imperfect. I am not an astrophysicist, but that is my understanding of how essentially the galaxy came to be in its broad general state.
I guess that's how I would imagine it to be too.
So cool. Okay, and I'm going to leave it there because that is not my expertise. You know what else? I just checked out Stephen Hawking's briefer history of time. He wrote a brief history of time, and then they got it down, and he wrote briefer history of time. I read chunks of a brief history of time when I was like 16, but that's more than half my life away now. So I don't have it all. I don't have it all in my head anymore. So I just actually checked out literally last week, also when I got this book, but I haven't reopened that. So, okay, sounds good. Marissa, I haven't heard from you. I don't know.
This has always been a subject that fascinates me, so I just thought I would check it out.
Cool. And you did hear like my little, I mean, not that it's super important, but you did hear like my little spiel on kind of like why I have some education in the, I have substantial education in the ancient world, but I'm not like actually a history major. I'm like a theology major, and I was a classical studies major, or I'm a theology master and classical studies major.
Oh, okay.
Yeah. So, cool. Sounds good. I'm
how did that stir your interest in this subject?
Well, so ancient, I'm very interested in the ancient world. And the other thing is I'm very much, I am actually aiming for the priesthood in the Episcopal Church, not in the, it's actually the American branch of the Church of England, or it's not quite like that. It's the American branch of the Anglican Communion. And so so that's why I study theology. And the other thing is I think that but I'm very interested in systematic theology, which is kind of like the word that they teach you in the German-speaking world for philosophical theology. And I don't know if that's also so common in the English-speaking world. I'm not quite sure. So I have no problem revealing this. I feel very led by God. I'm very interested in God in sort of like a scientific sense, because obviously we're talking about this right now, like definitely very much like a scientific rationalist, like very much like this is kind of an extreme, but sometimes you have the stereotype of like religious people don't believe in evolution or something like that. That is not me in any sense. And I think it's like very interesting because I'm like, oh, I feel so personally led by God in all these sense. Like, for example, being in Vienna doing my master's, it's been a really amazing experience, blah, blah, blah. And then I kind of contrast that with, okay, like, one of the things, of course, we're going to hear about is like hunter-gatherer societies. It's just going to be a refresher, I think, for you guys. It's basically high school level or like intro college level. One of the things that really interests me about like prehistory is, from a theological standpoint, like what is God's role in kind of like these where people are starving to death because they can't find food or blah, blah. So it's just like a very, I'm very interested in that. I'm very interested in like the actual history because it also, I feel like, has a deeper theological and philosophical meaning for me. But that's my personal interest, I would say.
Okay.
So
cool.
how do you reconcile your religion with the problem of evil and the evolution and all that kind of thing?
Absolutely, yeah. I mean, that's kind of what I'm referring to. So that's a bigger topic. One, I don't have a perfect answer to that. The second answer, so I will actually answer the first part of that question. So Marissa, I don't know if you're familiar with the problem of evil, but the problem of evil is basically the idea of if we have this like perfectly good God, how is it that like people are suffering, or not only people, like animals and plants suffer? How can we?
Right.
How can Christians make the argument that God is perfectly good? My answer to that is, like, if you take a look at infinity in mathematics, like how do I get to the number infinity? Basically, I take any number, I take any numerator, any positive numerator, and divide it by 0. And that's how you get to infinity. But, whether you divide 1 or 200 or 10,000 or 100 bazillion by 0, you're going to get, you cannot divide a number by 0. But as you approach 0, as you approach division by 0, you get, the limit is infinity. The limit of any numerator, any positive numerator divided by 0, as it approaches 0, is infinity. And so for me, how I answer the problem of evil is like, I think there clearly is evil in God, in the sense that there's evil in the world and God is everything. So there has to be some amount of evil in God. I just think that God's good is so much infinitely larger, that like unimaginably infinitely larger. And I think that like kind of all of the evil of God is like contained in the creation, and all the suffering of God is contained in creation. I do think there's a part of God that extends beyond the creation. And so that's how I kind of reconcile it. Like I do think there is some evil in God. It's relative to the size of God, infinitely small. That it's quite literally negligible. And so we can say that God is like perfect kind of in the limit if you think of it in a calculus sense. But that's my personal interpretation that most people would not agree with. But anyways, I don't want to talk too much long. I mean, you may or may not disagree with, I have no idea if you're going to agree with that or not. And I'd love to do it, but I would love to say that discussion for another time.
Right.
So I'm going to return here to Marissa. Would you be willing to pick up right here at this life began in a world?
Sure. Life began in a world that was warm but soundless, apart from the wind and the sea. The wind stirred an air almost entirely free from oxygen. With no protective ozone layer in the upper atmosphere, the sun's ultraviolet rays sterilized everything above the surface of the sea, or anything less than a few centimeters beneath the surface. As a means of defense, the cyanobacterial colonies evolved pigments to absorb these harmful rays. Once their energy had been absorbed, it could be put to work. The cyanobacteria used it to drive chemical reactions. Some of these fused carbon, hydrogen, and oxygen atoms together to create sugars and starch. This is the process we call photosynthesis. Harm had become harvest. In plants today, the energy harvesting pigment is called chlorophyll. Solar energy is used to split water into its constituent hydrogen and oxygen, releasing more energy to drive further chemical reactions. In the earliest days of the Earth, however, the raw materials were just as likely to have been minerals containing iron or sulfur. The best, however, was and remains the most abundant, water. But there was a catch. The photosynthesis of water produces as a waste product a colorless, odorless gas that burns anything it touches. This gas is one of the deadliest substances in the universe. Its name? Free oxygen, or O2. To the earliest life, which had evolved in an ocean and beneath an atmosphere essentially without free oxygen, it spelled environmental catastrophe. To set the matter into perspective, however, when cyanobacteria were making their first essays into oxygenic photosynthesis 3 billion years ago or more, there was rarely enough free oxygen at any time to count as more than a minor trace pollutant. But oxygen is so potent a force that even a trace spelled disaster to life that had evolved in its absence. These whiffs of oxygen caused the first of many mass extinctions in the Earth's history, as generation upon generation of living things were burned alive.
Very nice. Okay, cool. Any commentary or anything like that before I show you guys some photos? Okay, no problem. No, I wouldn't expect any commentary. I just think this stuff was super cool. Like I found this book. I was like, again, I can only recommend it. A very short history of life on Earth. Like you can read it in like an afternoon. It's super cool. Okay, so these are some photos I have from this book on evolution. This focuses on this actually focuses on human evolution right here. So I'm kind of obviously springing forward, but I did think this was kind of like a nice place to kind of break this up a little bit because we did some reading already. I gotta rotate this. I'm sorry. So obviously these are photos that I took out of a book. This is a cave called the Rising Star Cave. It is found in South Africa. It is part of the Cradle of Humankind World Heritage Site in South Africa that has yielded more than 1,500 bones of Homo naledi, a previously unknown fossil humanoid. Not humanoid, hominid. The chamber containing the bones, which I believe is also a humanoid, but anyways, the chamber containing the bones, which were an extraordinary state of preservation, can be reached only through a 7-inch wide window chimney right here. As a result, scientists hired for the Rising Star expedition were selected partially for their build, and it includes 6 women because they had to be able to squeeze through this tiny, tiny hole. So as you can see here, this is a human skull. Unfortunately, I cannot rotate it. And this is also pieces of humanoid skulls, pieces of humans. I'm sorry that I'm not able to rotate the image right now, but I'm not. So this is a specimen that is also recovered from South Africa that is about 2 million years old. It was discovered, the first specimen was discovered in 1924. Together they paint a portrait of a group that demonstrates a significant hominoid evolution and led to the appearance of Homo, our own genus. And then I don't think there was anything that I really wanted to. This is a small fraction of the find from that cave in the Rising Star Cave in South Africa that I had wanted to show you. So that's most of it. Let me see. I got a couple other pictures I want to pull up. This is, as you can imagine, obviously parts of, these are more from the Rising Star Trove. We have no other fossils of ancient mammals at that site, and there's no signs that the remains were carried away by water. So the question is, like, why are there so many fossils at this cave, inside of this cave? When we have, like, it doesn't seem that a mammal brought them there. It doesn't seem like there was any water brought them there. One thought is, of course, that this could be a funeral site. Pretty standard hypothesis, I would say, but worth considering. So anyways, that's what I want to show you there. So here we have some ancient Homo sapiens. I'm going to try one more time. Nope, not going to get there. Ancient Homo sapiens skull. This was originally dubbed Cro-Magnon from the rock shelter found in France, or where this was found in France in 1868. We have other specimens that are similar in Italy, Romania, elsewhere in Europe, and these are now today generally referred to as early modern humans. We have evidence that they used stone for weapons, so that's of course the Neolithic era, and they created beautiful cave paintings for themselves. On the what does anybody have any guess what this image is? You do kind of have to try and rotate it in your head, or maybe you could literally rotate your head and see what do you think this image might be? Any guesses?
Looks like a hand. Looks like a hand to me.
That's pretty close. It's not. It isn't a hand, but what else? What else?
A foot?
A foot. This is a foot, or at least this is what scientists say. Maybe it does look like a hand, doesn't it? Yeah, and it's a Neanderthal foot. Homo sapiens is native to which continent? Does anybody know?
It originated in Africa, Central Africa.
Exactly. And what continent are Neanderthals indigenous to? It's not Africa.
Europe?
I don't know about indigenous, but they were certainly present in Asia and Eastern Europe.
Yeah, exactly. Yeah, exactly. Europe, and you're right. They definitely were in Asia too. As soon as you said that, I'm like, yeah, they were definitely in Asia too. So Neanderthals, a couple small things. One, as we know, they are extinct. Everybody knows that. Two, they had larger brains than humans, were expected, or were probably, based on their skull size, more intelligent. We also do have some very limited, but some amount of Neanderthal art. So we do know that they had, obviously, like artistic abilities. And one thing that is one of the ways that we also know that there were a lot of Neanderthals in Europe is, in particular, people who have European biology today have a larger share of Neanderthal DNA. So Neanderthals did mix and commingle with Homo sapiens once Homo sapiens arrived in Europe. And again, people of European origin have Neanderthal, significant portions of Neanderthal DNA. I can't quite remember. It is single digit, but it's definitely there. I'm going to skip this. That's an orangutan. That's also a modern orangutan. It was more making a point around evolution. I think the point is clear from the image already. So, okay. So, who wants to read? I guess we just had Marissa. So, Roger, you want to read here?
The breakup of the supercontinent Rodinia began around 825 million years ago. Never heard of Rodinia. I've heard of others, like Pangaea and so on.
Right, that's the only one. Yeah, me too, before this book. Yeah, sorry.
It continued for almost 100 million years, leaving a ring of continents around the equator. The breakup was accompanied by a massive volcanic eruptions that brought vast amounts of volcanic rock to the surface, much of it igneous rock or basalt. Basalt is easily weathered by rain and storm, and many of the newly rifted land masses were in the tropics, where greater heat and humidity made weathering especially intense. Wind and weather not only sloughed basalt into the oceans, but they also dipped immense amounts of carbon-containing sediments into the depths, out of reach of oxygen. When carbon can be oxidized to form carbon dioxide, the Earth is warmed by the greenhouse effects. But with carbon removed from the atmosphere, the greenhouse effect stalls, and Earth cools down.
Perfect. That's good. So basically, what we had then, I realized now what I was actually aiming for on this image was just as much the timeline, but the one of the things about what this did cause was an ice age. As you guys probably know, there's a ton of ice ages in Earth's history. So here we have a timeline of life on Earth. So first thing, earliest signs of life, that's actually about 4 billion years ago. It was pretty quick. It was not. It was just this. According to this book, again, this is where I'm getting a lot of my information. Only a few 100 million years, 300 million years after, essentially the Earth formed, and that actually is not that long of a time frame. Again, we didn't have any oxygen, blah blah blah. So I thought that was pretty interesting. Then we have the first glaciations a couple billion years ago, about 3 billion years ago. As we can see here, only about 2/3 of the way of life existing on Earth. So that now we're talking about 1 billion years ago. Actually, even less than that. I think it's like 600 million years ago, 700 million years ago. Earliest plants on land, Cambrian explosion. I don't remember what this one even means right now. The Ediacaran biota. I don't remember what that means. Break of Rodinia, which also caused some glaciation from the process that Roger had just read us. And algae and fungi diversify. Then this line right here is now. So that's what this dashed line represents here on the side. I don't know if you can see my mouse. But then we have, it's now obviously projecting the future. We're going to have a final supercontinent, and then plate tectonics will stop. So all the continents come back together at some point. Obviously, this is not going to occur within our lifetimes. But then, at some point after that, you also have extinction of life on Earth. And that's not due, according to this author, it is not due to the sun exploding, which will happen at some point. I don't remember exactly how many billion years from now the sun will explode and consume the Earth as well. But there's also going to be a time where kind of internally the plate tectonic stops, and a lot of the natural processes that bring heat from the center of the Earth outward, volcanoes, things like that, as plate tectonics stop. Expecting at some point after that an extinction of life on Earth. So I think that's I thought that was pretty interesting. I'm not super worried about it. It may sound scarier, like an extinction of life on Earth, because it is a very long time from now, and it's hard for me to worry about things that are going to happen, in 500 million years. That's just me though.
It says plate tectonic stops, but plate tectonics is still going.
Absolutely.
Surely.
That is in the future. That is in the future. It's like, I don't know how many 100 million years in the future. So it's not making a comment about now. It's making a comment about the future.
Right.
This one wasn't absolutely essential, but I just thought it was so interesting that I was like, we got to do it. So, Marissa, if you're not going to be embarrassed by talking about some human bodily processes, this I think is a super interesting session if you'd be willing to read it, starting here, starting at those that were a little larger. Otherwise, I can read it.
Sure. Let's see. Those that were a little larger evolved a particular place for nutrients to enter and for waste to diffuse out again. That place was the mouth, although it also served double duty as an anus. The development of a distinct anus in some species of otherwise undistinguished worms led to a revolution in the biosphere. For the first time, waste was concentrated into solid pellets rather than being a general wash of dissolved excrement. These feces sank quickly to the sea floor rather than diffusing slowly, and this led to a literal race to the bottom. Oxygen-sucking agents of decay began to concentrate their efforts near the seafloor rather than throughout the water column. The seas, once turbid and stagnant, became clearer and still richer in oxygen, enough to enable the evolution of larger life forms. The development of the anus had another consequence. Animals with a mouth at one end and an anus at the other have a distinct direction of travel, a head in front and a, quote, tail behind. At first, these animals lived by picking scraps off the thick carpet of slime that had lain on the ocean floor for more than 2 billion years.
Perfect. And then will you jump over here?
Sure. Animal life burst into visibility sometime around 635 million years ago in what is known as the Ediacaran period. This first flush of complex animal life was a flourish of beautiful frond-like forms, many of which defy categorization. Although some were animals, others may have been lichens or fungi, or colonial creatures of uncertain affinity, or something so entirely foreign that we lack any means of comparison. One of these, a strikingly beautiful creature called Dickinsonia, was broad but pancake flat and segmented. It's easy to imagine one gliding gracefully over the sediment, much as flatworms or sea slugs do today. Another fossil called Kimberella might have been a very early relative of mollusks. Others, the rangiomorphs, are even harder to categorize. They resembled plated loaves and probably remained in one place throughout their lives, although, like strawberry plants, they budded off new colonies round about the parent. The world of these strangely beautiful alien creatures.
Yeah, and I'm that might have been all. Let me see if there was. Let's see what this next one is. Yeah, so that was what we want to get through on that one. So beautiful. Thank you very much. Okay, and then here we're gonna jump to some. We're gonna jump to animals now. So Roger,
I thought we've already been talking about
well,
animals.
we are.
It
Sorry, we're
seems
talking
to
about
me
land
to-
animals. We're talking about land animals now, jumping forward several
Right.
100 million years. Skipping the whole evolution of vertebrates from invertebrates and blah blah blah, because I do actually want to get to a little bit of human history. But yeah, Roger, would you pick up here?
The first animals on land were small arthropods, centipedes, spider-like animals such as harvestmen and springtails, close cousins to the insects that would soon evolve and become the most successful land animals the Earth has ever seen, both in terms of numbers of individuals and of species. Throughout the Devonian, forests grew and spread. The forests would not have looked much like the forests of today. Early forest trees, the Cladoxylopsids, for example, were more like giant reeds, shooting hollow branchless stems 10 meters or so into the sky, terminating in brush-like structures like fly whisks. Later additions included plants similar to club mosses and the field horsetail, Equesterum, found in damp places even today. The modern forms are very small. Their ancient relatives were giants. The club moss, Lepidodendron, grew up to 50 meters tall. The horsetail was 20 meters. Most of these trees were hollow. They contained no heartwood and were supported by their thick external rinds. Some of the trees, such as Archaeopteris, looked more like modern trees and had heartwood, except they shed spores as firs do, rather than responding with seeds. Surely that's like pines today, isn't it?
Yeah.
This plenty of plants would seem at first a source of food too good to miss. But for millions of years, plants were off the menu for animals. Woody tissue is tough and indigestible, and the plants also produce chemicals such as phenols and resins that animals were unable to tolerate.
Okay, that's good. That's good enough. Yeah, that I think is terrific. Thank you very much. Let me jump forward here.
I think what's been missing so far is the question of how life originated in the very first place. Well, we still don't know that.
Right. Well, so that does that is in here. I kind of skipped over that part, but basically, how this book describes it is there were essentially pools of chemicals that the Earth was forming. Again, no oxygen in the atmosphere, as we heard, and so there's like pools of chemicals, and these chemicals kind of come together. And what I've also heard, this actually didn't appear here, so this is hearsay, take this with a grain of salt, is that like a lightning likely played a role, that kind of like lightning struck these kind of pools of chemicals that kind of came together. And how this book again describes it is that they somehow happen to have, these are single-celled organisms, the equivalent of single-celled organisms, right? Eventually they just kind of split off, and for some reason keep splitting. I don't quite know that either. And my understanding is of where we are on kind of answering that question. This is a dated answer, but I did read this, I don't know, 5, 6, 7 years ago, something like that. Is that scientists have been able to essentially take broadly the chemicals that were likely in existence, or the minerals that were in existence in early Earth, kind of stick them together, and then to kind of mimic that lightning, zap them with electricity. And they do actually generate what we would things that we would consider very similar to single-celled organisms. However, my understanding of where we were as of a couple of years ago is that none of those organisms continued to regenerate. So they sort of have be alive. You'd zap these chemicals, these pools of chemicals with electricity, and eventually, sometimes or eventually you'd get the equivalent of single-celled organisms. However, they wouldn't reproduce. So we're going to jump forward, run through this timeline really quick. So expansion of Homo sapiens outside of Africa and earliest art, 120,000 years before the present. 70,000 years ago, massive population growth in Africa. 60,000 years ago, Homo sapiens discovers Australia, which I continue to be amazed by, because I'm like, how did these people manage to land in Australia? Yeah, sure, you go all the way from Asia, you go down, you can go down through Indonesia or whatever, but man, there's a big distance between Australia and Indonesia on a boat. Same thing with Easter Island. I'm like, Easter Island in Chile, how people landed on Easter Island is incredible to me, unbelievable. So I don't know, obviously, we don't know how these things actually happened exactly. Homo sapiens in Europe, aka they were there prior, but cave art in Europe and in Southeast Asia. Earliest pottery, less than 20,000 years ago. Earliest agriculture, less than 10,000 years ago. Crazy. Okay, with that, just out of the interest of time, I am going to jump forward and actually talk about some of actual human history. Homo sapiens is interesting in the sense that grandmothers play a role. Obviously, this is a part of a civilization, but you have hunter-gatherer societies. But not only mothers, but also grandmothers and grandfathers play a role. Menopause is in some ways considered to be a biological or an evolutionary advantage, in the sense that it prevents women from having children at an older age. What this does is it actually increases their likelihood, in theory, of having successful offspring, not only because their eggs are of higher quality when they're young, we all know that, but secondly, because it also frees up their time. If women were occupied taking care of their own children in their 70s, which they still frequently are, right? This is kind of what they're doing in an extended sense. But then, some of your offspring from when you were younger died, or some of your offspring's offspring will die. What this does is menopause increases, in theory, one hypothesis is it increases the likelihood that your grandchildren will survive, because it kind of gives, more adults per child. That's kind of the idea. Next thing I wanted to comment on here. So I'm just looking here. Yeah, I'm skipping over all this. Not super important. It's kind of stuff we talked about. So, world history review, essentially through Sumeria, is what I do also want to cover in the next 6 minutes, if we can handle that. So we begin with essentially the Paleolithic period. So the Paleolithic period, they don't have any agriculture, of course. This is marked entirely by the use of stone tools. Paleolithic essentially meaning the Old Stone Age, the first Stone Age, the earlier part of the Stone Age. We have two essential groups of people here, or two essential societal structures. The first structure is prior to the Neolithic Revolution, which is also known as, we'll get to that in a moment. So the first societal structure is the hunter and gatherer structure, or frequently called the foraging society. These are composed of small groups of people who travel together from point to point to get food and animal according to frequently weather. I mean, that's a huge part of actually why humans are spread out across the entire globe, is the hunter-gatherer need. You'd follow the animals, for example, that you needed. And as the animals migrated, so did you. And that's why humans actually expanded across the entire globe. There's no reason for permanent shelter, and your likely number of possessions would fit in something like a modern backpack, because you walked to get to follow your animals in the next place. The other option, essentially, this comes a little later, is the pastoral society, but this is also part of the Paleolithic area, the Old Stone Age. Pastoral societies are characterized by the domestication of animals. That basically means that you have a herd of goats or something like that, or sheep or whatever, who are frequently your source of food, and they and so you would follow your animals around and make sure that they had food that they could eat. People also had very few personal possessions. Again, the only tools, the primary set of tools would be stone tools. But people did experiment with domesticating animals more. Very likely, dogs came around in the Old Stone Age. Estimates vary between 11,000 and 40,000 years ago. Today, there's a big debate on when exactly the dog evolved. But yeah, and so, but kind of the idea of like, hey, we can raise these animals. This leads to the idea of the agricultural society. Hey, if we can breed these animals, like maybe we can breed these plants too. So around 8,000 BC, between 8,000 and 3,000 BC, we enter the Neolithic period, the New Stone Age. This is, again, I used the term earlier, the Neolithic Revolution. You get the agriculture, the invention of agriculture. So we have, as I mentioned, so that would be 8,000 BC, so about 10,000 years ago is when it would began. It would have began. There we go. To 3,000 BC. And what that means, essentially, is that people stop living in, they stop following necessarily the animals that they need to keep them alive, whether they're a hunter-gatherer society or a pastoral society. There's this process of following animals. And instead, we plant plants here. That means all of a sudden that we can stay here, and in fact we have to stay here because we need to harvest these plants at a later time. So if you were doing if you're having your first agricultural society, where is that going to be based? Probably, geographically, where will that be?
Well, we talk about the Middle East, don't we?
Right. Oh, sorry, and that is
Mesopotamia and then the Indus Valley.
Well, so that is absolutely true. That is absolutely true. Obviously, not obviously, but that is absolutely true. That is the first place that we know of agriculture, and in all likelihood, that's also correct. But what I meant by that is, would you want it in mountains? Would you want it on the ocean? What kind of geography would you want it in a forest? And what kind of geographical area would you have your agricultural settlement?
River valleys.
Exactly.
Near a source of fresh water.
Exactly. And why? But river valleys in particular is very good. Why river valleys? So obviously a source of fresh water. We did hear one thing. It's very, very. That is the most important, right? Obviously the most important. But there's two actually other major reasons that river valleys, river banks are extremely important. Do you guys have a guess at what those might be?
Well, one of them would be alluvial plains and places where plants like to grow.
Exactly. So rivers, river banks, river valleys, river deltas. Obviously, we hear about the Fertile Crescent. Yes, a lot of good sediment carried in rivers. Lots of minerals carried in rivers. Also broken up, so it's not too rocky. You get the process of the water breaking it up makes the sediment very nice, and so plants love it. Lots of minerals and great things. There's one other element that it said source of transportation. So rivers being a crucial source of transportation.
Oh.
It is kind of surprising, and also we just learned that they're not totally necessary in a certain sense. Like the transportation is more optional than required. If you're an agricultural society, but those are kind of the three reasons that come up. Again, also, how do we build theories of history? We build theories of history by saying, this is what happened. Let's come up with why it happened. It's not the other way around, that we necessarily, we don't predict the future exactly. So kind of our theories of history are in many ways like non-falsifiable. So that's kind of a problem. But yeah, okay, sounds good. Next,
I mean, one of the things that was going to happen next was the discovery of metallurgy and so on.
absolutely.
And I have no idea how that was first discovered.
I do not know that either. I think that's very interesting. I mean, I guess people had, again, also theologically interesting questions. Whether we all have our telos, our purpose, but how these kind of amazing things just happen to be that we also have to be in a universe whose scientific structure allows these chemical pools to come together that get zapped with electricity and then become things that eventually become humans. Like, I'm very interested in all that, but that's kind of beside the point. But of course, that takes us away from the stone era into like the Paleolithic or the Neolithic area. Into what era? Do you guys know?
Well, we would call it the Bronze Age in Britain, but
exactly.
Some people say the Copper Age came first.
Really? Okay. I've never heard that. My theory of history didn't have that delineation. May have, may not have.
Well, the oldest metal tools found in Britain are copper, and it was sometime later that they turned into bronze, which was more useful than copper.
Yeah, absolutely. Yeah. I'm not an expert, but that totally makes sense. I have another question actually before we kind of jump to the next era. What does, again, this is more of a theory of history thing. What does agriculture do for us? So, like, what I mean by that is you have, I guess I'm asking a question about division of labor. Let me give you that hint, because otherwise the question isn't clear anyways. Relative to a hunter-gatherer society, for example, or a pastoral society, what does agriculture do in terms of labor?
It means that people can be settled.
It means that people can be settled. Absolutely, that's true. Right. That's absolutely true. I'm going for something else. Let me see if I can nudge you in the direction.
Specialization?
Exactly. Mm-hmm. And why? Why does it enable specialization of labor?
People are certain, I guess, different people are more adept at doing different functions in society.
Right. Absolutely. That is absolutely true. But one thing it does, so one thing is with agriculture, for the first time, even 5,000 years ago, we're having food surpluses. So that means, in a pastoral society, you collect your food, or a hunter-gatherer society, you collect your food quite literally on a daily basis. Quite literally every single day, you have, this is your food for the day that you collect that day. In an agricultural society, you do have food surpluses, essentially, for the first time. The other thing about it is when you have that, and one of you two, I can't remember exactly who, just mentioned this as well, kind of that the fact that you have this not sedentary, that's totally the wrong word. You have this settlement. You have a settlement. You have a fixed place where you stay. One, it allows you to collect more possessions, right? So that's a part of what leads to metallurgy, I'm sure, is that, like, why would you carry, when you find some metal, like, why would you typically carry that around? Why would you do any experimentation with that? You can essentially have the things that you can carry on your back as you go and follow the animals wherever you're going for the next day, kind of thing. But when you have a fixed place, like, I'll grab this metal and leave it over by my settlement, and then it just happens, I don't know, I'm throwing something out there right now, but you kind of play with it. It doesn't have to be just metal, it can be anything, right? So it does allow for kind of more experimentation. And again, but the more important thing is that you do have this food surplus, which allows people to have some sort of specialization of labor. So that can be religious, but it can be also things like armies, allowing development of writing, blah blah blah. So that's and also it totally changes the size of settlement that you can have, because you can now have a settlement with thousands, literally thousands of people, which is not possible when you're following animals around. In fact, like as a hunter-gatherer, you have too many people, you're all going to die because you're going to eat all the animals that you're kind of following and looking for. So, so that's another thing. It allows larger societies. Okay, cool. Any questions, comments before I kind of move on to the next thing? We'll be done in about 10, 15 minutes. We'll be wrapping up.
Okay.
Cool. Okay, sounds good. So we already mentioned that. So what I wanted to mention, obviously we're running through a lot of million years of history in an hour and a half, but sounds good. So there's a couple things about this. So one thing is this also changes geography. Kind of a small. In theory, this is a small change, but we're clearing for the first time. Humans are actually shaping the earth. Humans are saying this land will now be a field. This land will now be my permanent house. So culturally, that has an enormous cultural impact where, first of all, it's kind of a now us versus them frequently. Like you and your family or your clan have been settled on, this hillside near this river. And now when other people come here, previously when everyone was hunter-gatherers, okay, you go here, I'm not really connected to this place. I'm just following the animals. All of a sudden, this is my place. Like my family has been here, I've been here my whole life, and my family was here their whole lives. And so you kind of you do have more of like an us versus them mentality. And when new people would come in, obviously less welcome. In addition, animals are domesticated for the first time. So in the pastoral, that's not entirely true in the sense that, like, this is what the book I found said, but I'm like, well, what about the dog? Because the dog was very likely, part of the hunter-gatherer society as well. But many animals, for example, like oxen, were not previously domesticated. There was no need to domesticate an ox